Hello. In this lecture we will discuss the Phase 2 negotiation. In IKE version 2, the term Phase 2 doesn't really exist. It is actually replaced with the term child SA, and create child SA. Okay, so we got to this point and discussed what happens in the IKE initialization and auth phase. At the tail end of the auth phase, the two sides negotiated the encryption and integrity algorithms for the actual encryption of traffic. So, the actual replacement for Phase 2 happens within the auth messages. The two sides would have the information they need to create the encryption and hashing keys or integrity keys for the negotiated traffic selectors. Based on the keys generated, the skd is used to generate a key mat. This key mat provides the encryption and integrity keys that will be used for the actual encryption of traffic. If you recall, when we discussed IKE version 1, we explained the concept of outbound SPI and inbound SPI. As the two sides negotiate Phase 2 or the child SA, they will have an ASP, SPI generated. The initiator sends its SPI in the SA payload, which will be used as an inbound SPI for the responder. The responder sends its SPI in the SA payload as well, which will be the outbound SPI for the responder, and the inbound SPI for the initiator. Okay, so it's been a while since we talked about SPD and SAD. Let's refresh our memory. So, the SPD is the Security Policy Database. This basically describes what traffic should be protected behind an IPsec connection. Then you have the Security Association Database. This will keep a list of existing Phase 2, or in case of IKE version 2, which child SAs exist. This database basically has what encryption and integrity keys will be used to process this traffic. So, what happens when there is no existing SAD entry into the database? The initiator in that case will start the SA init messages, will progress through the authentication phase. After auth, the initiator has the outbound SPI and inbound SPI. Same with the responder. This is opposite. The outbound SPI for the initiator is the inbound SPI for the responder, and vice versa. Now, subsequent traffic will be encrypted and decrypted using those keys. Okay, so we go back to the negotiation for traffic encryption. Based on the authentication, the two sides arrive to the same set of keys. Both the initiator and responder uses the formula of pseudo-random function of the skd, against the concatenation of nonce initiator, and nonce responder. So, this would produce the encryption and integrity keys. The output of the operation is the same on both sides. The first series of bits will be used for the encryption key initiator, and the second set of bits will be used for hashing key for initiator. This will be followed by encryption key responder, and then integrity keys responder. The initiator would register this information in the Security Association database. It would basically list that for traffic going from the traffic selector initiator to responder, use this outbound SPI. This entry in the Security Association database is populated with the encryption and integrity keys that should be used for this traffic. It will hash and encrypt the traffic and send it out in its merry way to the responder. The responder gets this ASP packet. This ASP packet has an SPI matching the inbound SPI that resulted from the IKE auth process. It will extract the packet, it will decrypt with the encryption keys for the initiator. Then it will run the hash operation using the integrity key of the initiator. If everything checks out, the traffic is sent to its intended destination, or processed locally if this packet is for the VPN gateway itself. Now, the result of the IKE auth process is the generation of those SPIs on both sides. What happens if there is additional traffic that needs to be encrypted that doesn't match the existing pair of traffic selectors? Also, the security policy database specifies that this should be protected traffic. The security policy database also has the peer to send the traffic to as the responder, which currently has a child SA in place. In that case, the initiator would send an IKE message with create child SA. It will reuse the existing I session. This message has the new traffic selector. Those two message pairs for create child SA has new nonce initiator nonce responder. Those nonces are sent in IKE in the create child SA. So, the two systems would run the key mat operation again. However, this time with the new nonce initiator, nonce responder values. Both sides would produce a second set of encryption integrity keys and an additional outbound/inbound SPI to protect that traffic. Hopefully this lecture was helpful. We will discuss more in the next lecture.